Hello and welcome back to another devlog for Glaucus Linux. In the previous devlog, we've successfully bootstrapped stage 1, which is the toolchain. For this log, we're going to attempt a bootstrap of the cross-compiled system, which is a stage 2 bootstrap. So let's see if we still have the files from the previous bootstrap. I resolved the issue which was slowing down the bootstrap of the first stage. It was a silly one, as expected. Make flags were not being applied for the toolchain stage, which was a bit silly. So I moved it out of that block, sorry. So it's now being applied regardless, which is what we want. So, yep. And as I said, I was fixating the number of make jobs to make things more deterministic and, to get a rough estimate of how long this will take. Regardless, let's see. Yes, I've also been improving the bootstrap process a bit, particularly bootstrapping nim. And yeah, I think, let's see. So yes, we have a correctly bootstrapped nim. Anyways, let's get back to rad and attempt a bootstrap of the stage 2. There will be a lot of failures until this stage fully builds, but hopefully they won't be as significant as the ones from the previous stage. Yeah, it shouldn't be trying to fetch flex again, because I think I already had flex fetched before, but whatever. It's going to take some time. Let's see. Oh, I probably shouldn't have done that. Maybe a du-s. Yeah, I think this is going to take some time. Well, I'm not going to bore you with this, given how slow the internet connection is. I'm going to pause this here, and once it's done fetching all the packages. Oh, that was quick. Yeah, I take that back. Okay, should be checking everything. Now, this fetch process actually downloads the source of the package. If it's a if it's a tarball, it uses curl. It's a wrapper, a thin wrapper around curl, and then it verifies its checksum using XX hash. I think it was the uh, XX hash 3, the 64-bit one. I forgot if it's the 128 or the 64-bit one, but it's one of them. The faster one, actually, which I think was, it probably is the 128-bit one. Yeah, so for the kernel, we're using the binaries directly from Cache OS's repositories. The kernel is libc agnostic, so you can use whatever is available on your host system as well. In fact, I think I'm going to do that, like provide an option to build your own kernel or utilize what the host system has, since that's also an option. And I'm actually surprised, like we've just built 13 packages without errors. Usually when there are huge or significant errors, it would fail almost instantly, as you saw. But hopefully, like things are going smoothly. I'm just going to run a simple this. Yeah, this is nice actually. We don't have that many errors. It's mostly just, yeah, things are just building fine for once. Yeah, usually things are this smooth, if not smoother, but one wrong command, every once in a while, or every a group of updates just would cascade into a bunch of entangled mess that would take some time to resolve, but I've gotten used to it. So um, let's see. So I'm still evaluating some of these alternatives. For the SSL library, LibreSSL is actually a very good option. It's audited, and it's mostly correct, and it provides a libTLS, not that many packages depend on, but it's needed for some packages, as well as a CA-certificates replacement. So it also has a CA cert. It provides that as well, which some downloaders or some packages that need HTTP and stuff like that need, like curl and wget and so. And wow, I hope nothing is wrong here, because this is the first build in a couple of months and it's just blasting through them. Like we've gone through 21 packages in 3 minutes. Now that's impressive, I know. That's nice. But if I had to guess, things will start breaking when we get to binutils and GCC again. That's yeah, it's a bit of a sanity test, or that's what I consider it. The reason is, I won't know if the toolchain tools, or the tools or the stuff or the compiler build in the toolchain or in stage 1 is actually viable to build itself, only until these two packages build fine, and then things should, yeah. So I was just waiting for this thing to happen, because things are more fun when they break. Hopefully it's nothing serious. Yeah, so we're getting a simple error. If you recall the error that we actually got, when we were building GCC, we got a similar error, I think. So we were using the make build system for ZSTD, and this was the cross build. Now, yes, so we can cheat a bit here. I'm going to skip, let's say I'm going to check what, so it, does it depend on GC? Yeah, oh, this is a runtime dependency on GCC. Hopefully, libzstd, ltrans, text.std, the threaded dynamic. Yeah, I just hope that it doesn't require libgcc this early on, because otherwise I'd have to move it. It's going to be a circular dependency, because GCC requires zstd for LTO and other stuff as well, as a backend for LTO when zlib is not available. So it defaults to zstd nowadays, and zlib is used as the fallback backend for LTO. Anyways, let's try to solve this. Let's cheat a bit. So we're going to not pass any C flags here. That's the quickest way to check if it'll work or not. And I'm going, I think, yeah, we still need to go through all of these. So I can just restart this again. Normally it shouldn't fail here, and I wouldn't recommend you retry a stage that fails again, like that, except for when you're starting from stage 1 and you want to rebuild that. But if stage 2 fails, you'll need to build stage 1 again, and then stage 2, since these steps are intertwined. I used to have a separation, which I removed because stage 1 only takes like 10 minutes, and it doesn't uh, like contextually, you need to go through these sequentially without failures. You can say it should be atomic, but in a sense. But yeah, for now I'm just going to rerun this just to go through these. I used to have the package builder produce tarballs for packages built in this stage, so I can skip all these building the same packages again. But I got rid of that because I didn't want to add more complexity to the package builder in this early part of the bootstrap phase. So for now, everything just gets, instead of, it's a bit more complicated. Instead of relying on a fake destination directory and then creating a tarball for that, which then like you need to keep and then extract to this system root or sysroot, things just get installed into this into a real destination directory, which is the system root directly. So like I skipped all this complexity for this stage in preparation for the following or the upcoming stage, which will be doing the exact same thing. Downsides are that you can't skip um, these builds quickly, but honestly, like once it works, again, I try to keep things going on sequentially. Like any breakage here should be uh, significant. It shouldn't happen in the first place, so it is what I'm trying to say. Yeah, so uconfig is a nice package. It's a package config replacement, also a lighter alternative to packageconf. Packageconf is also a great project, but for glaucus, we're going with something even lighter. I think it doesn't support all the bells and whistles of packageconf, like it doesn't support many environment variables, or the ones that are supported by package.conf, if I recall correctly, which is why I only use it for the latter parts of the Bootstrap process where I'm providing it instead of relying on whatever the host is providing. For earlier stages or for when starting from stage 1, yeah, I just documented these, so mostly like the Bootstrap process, not many distributions actually bootstrap from 0 or even from stage 1 these days. You'll mostly get a CD or a DVD or an ISO or an image file that's a stage 2 or a stage 3. And then you're expected to either use that directly or build or rebuild it as a stage 4, for your native system or whatever, like Gentoo or Fun2. But the bootstrappable projects, the live bootstrap, stage X, and all these cool projects, I think many of these efforts were uh, like pioneered by GNU geeks, bootstrapping from absolute nothingness and solving the supply chain attack. So glaucus used to start from stage 1, and it was like over the years, like we've managed to reach stage 3 and then provide ISOs of stage 3 that would run on real hardware. But recently I've become more interested in this. Suppose the case where there may not be a host system available. Where are you going to grab your tools? So you need to build them from absolute nothingness using a minimal binary seed or whatever. This is still an ongoing effort. I might leverage a minimal distribution that does this quite well instead of having to reinvent the wheel, or I might reinvent the wheel for Glaucus, who knows. I might find some shortcuts here and there for based on the alternatives or minimal list of software I'm using, who knows. And this is also another stage that I'm interested in doing. Like after an ISO is generated from stage 3, since it's run under QEMU, you can still use like the ISO is already optimized for this sub-ISA v3. You can still use the ISO to optimize for what I mean for native is the March and native and Mtune native, or I think it gets changed to generic or whatever, but it gets optimized for your native machine. And thus it will only run on your system if you went with this stage, so you won't be able to, like, it will be heavily optimized, even more so than this, and it won't run on other machines, is what I'm trying to say. But so far, these three, like, have been tested and are known to work. These two are not. Yeah, and for the bootstrap, like a bunch of binaries and packages are required. For the host system, we don't expect like it to provide the alternative software, so we mainly like if the implementation is simple enough, we use mostly the POSIX available flags for commands without relying much on, GNU-isms, Bash-isms, glibc-isms, and GCC-isms, whatever. Like the most basic standard flags available for packages if possible. And yes, as for uconfig, doesn't support setting a sysroot directory, so using it for uh, setting a cross-compilation directory and then telling it to use that's not possible, so you can't leverage the host version of uconfig. Instead, like you have to use one of these. These paths are created automatically. They are created on your host system, unfortunately. I'm trying to keep the pollution on the host system where glaucus is to be bootstrapped to a minimum. that is if a host system is being utilized in the first place, in which you are starting from stage 1, which is what I'm doing. I'm using Arch to build a stage 1, then go through 2 and 3. But for stage 0, you needn't worry about any of this. Again, I still haven't supported stage 0 yet. These are all stubs that are useful to have, to prevent where there are errors and such. And we have another failure here. So ZSTD. Okay, so it's working. But why did it fail? Um, so it failed because it was trying to create a static library. And yeah, this is going to be a fun one. It was trying to create a static library. And if I recall correctly, you can't disable the static library of ZSTD when you're using the make build system. So that's only, I'm going to show you this. So um, let's check for make files, and so I think it was the library. Let's see. Yeah, so it's the lib and then this. Yes. So it's possible to force. No, this is not this section. Yeah, so this gets run all of the time. And I'm not going to, am I patching it or not? I actually forgot, so yeah, I'm not patching it. Anyways, you can, like with CMake, uh, you can do a didn't it have a CMake build system? This is actually super weird. Like I recall it having a yeah, this is a okay. So it's under here, and it's under CMake, and there's also a Mason build system. So I suppose I can do that. And this is going to, we can check for it here. So yeah, so we can turn this off, the ZSTD build static. So, but we can't do that with the makefile based one. Now you might ask, so you are actually removing the static library over here, so why is it not working? Yeah, that's because we did something very terrible in the previous stream. If you paid attention, and I don't think like these things are hard to spot, or perhaps you did pay attention, but I didn't. So we did something terrible actually. Yeah. Okay, so we disabled the building of static libraries. This, I think, this disables the building of static libraries, if I recall correctly. So we can do it this, then we can do a lie, and then let's make it even more interesting. So now let's see. Okay, so enable static check whether build static libraries. So this builds static libraries for everything. Okay. So this has nothing to do with the support for building static libraries. I think we also did the same for GCC, which might have been the cause as well. So we can check as well. Oh, that was bad. And we broke Tmux again. I should have a timer for the number of times I've broken this. And I'm going to move this one down here, to the grounded section. Let's name it Tmux. I broke you again. I apologize. I just can't handle how fast we are. So I'm just kidding. I really need to figure out what's wrong with that Tmux issue. If you have an idea, please let me know. So find iname, configure static, yeah, so so it's also controlled by, yeah, most of these are enabled by default. This is actually weird. Like if this is just disabling support for static libraries. Yeah, it's at this point of time is when I usually go back and check the Git logs. Um, let's check these. So we can do a TIG build tool chain. Then let's start from here. So yeah, we disabled these here. And now we're forcing PIC on everything. Could that be the issue? I don't think so. Okay. So what I'm going to do here is let's go back to GCC and then do a TIG as well. So this is going to be similar, I guess. So I believe for GCC, yeah. Also for musl, did I do? Yeah, I probably messed something up. No, I don't think so. Should have been done here, and let's check this. Either ways, I'm only installing the headers here. This shouldn't have been an issue, but what? Oh, okay. So yeah, I'm disabling static as well here. So what I'm going to do is I'll undo what I've done here. Same goes here, and same goes here. I wasn't trying to disable the support for static linking. That would be stupid. I was just trying to disable building the static libraries that come bundled with some of these, not all of them. We still need to rely, like, wait, libgcc, that was being provided, no? libgcc .a? Wait, how is it being provided if I'm disabling build of static libraries? Oh, okay. Okay. Yeah. It's being provided because I overrided or overrode that flag here. So I was building libgcc.static separately, which was needed. Anyways, so this has become a bit of a mess. Let's clean up. And let's see, let's check all the changes now. So yeah, Delta is a very nice tool. We're going to start back from stage 1, and I'm going to pause the video, and hopefully we'll resume when everything is done. Yeah, so GCC just finished. Let's actually check if I change the order of these here just to rule out the dependency on libgcc. Now, I think so. Yeah, there isn't a direct dependency on GCC here. It's probably just a runtime one. Yeah, the order is probably just the same. Anyways, now I'm going to do a proper Trinity sec for the toolchain again. And let's wait until this finishes. So yeah, as you can see, it actually took, well, it did take a bit longer than I expected. It usually takes like 15 minutes, 17 minutes maximum. It's probably because we're recording as well. Or probably because it had to generate all these static libraries. Hopefully I'm not removing them, because we'd have to run this again. Okay. Yeah, so it finished. And we're removing these, the libtool files, or archives. Yeah, so let's try to again, everything looks normal here. Let's try a find unwanted, and yeah, these are all expected, which means yeah, so this is removing some of them, and the latter are probably removed by this here. Yeah, I should probably have disabled these just to be safe. You know what? I'm going to disable them now. Maybe keep the. Then let's do. We will have to run that again. But first, let's give it a try and see if it works or not. So fingers crossed. So I'm trying to find a three-letter word that works for this time indicator. This shows the time the command has finished. So the starting one, when it starts and when it finishes. So I had the word fan or fin, which means finish, but it also resembles the start time when it begins, so it didn't make sense to have it. So if there's, the hardest problem is naming things. So if there is a better name, a three-letter word that better represents this column, feel free to suggest one. I think I had TIM, which is short for time, but it didn't make sense. I also had TBA or TBF to be finished or whatever, but just didn't fit, the overall theme. Yeah, that's a bad one. We lost another Tmux pane, an important one. I can't actually see what's going on, and I'm going to watch over the logs from a different place. This is frustrating, I know, but so Libre SSL finished. I should probably, you know, trace these cross. So Shadow also finished. It's probably building zlibng now. Then bzip2 and pigz. Now it's probably building lz4 and then xz. So yeah, so far so good. Yeah, so we have reached ZSTD again. Hopefully it works this time so we can later on minimize the number of changed variables, to detect the issue better. And I think it failed. Yeah, it looks like, yeah, it failed probably. And we still have these broken windows. Yeah, so it's just broken. So yeah, so judging by the fact that we can run rad now. Probably the build has finished with a broken ZSTD once again. This is one of the weirder issues actually. I'll spend some time debugging it while I'm not recording. It'll probably be another silly bug. That probably has to do with, you know, PIE or PIC. Let's check the log again actually. So these are just warnings for bzip. Inlining failed against symbol standard error. Checking. So lib release. Recompile with FPIC because of this relocation against this symbol. But this bzip2, these warnings are actually more, they seem more significant. It's probably because when you're optimizing for size, the maximum aligned or inline instructions are actually decreased, if I recall correctly, compared to O2. Like that's one of the main differences between the two. Yeah, so O2 uses 5 for the cross jump while OS uses 1. So it's probably complaining about something similar. Anyways, like, I'm just happy we managed to build 20-something packages without breakages. Like, that in itself is a huge win. But for ZSTD, something is, it needs more testing, like until it gets back to its stable state, the tool chain. It needs some more testing, and hopefully you've enjoyed this video. See you again in a future devlog.